Hello, and welcome to Rangle.io's Start Your Migration webinar. My name's Michael, and I'm here with Prune, and we're going to be talking about migrating Angular 1 code bases to Angular 2. So there's a couple different things we're going to be talking about. Challenges of migrations, upgrade strategies, migration prep, and some upgrade examples. Every application is different, and their upgrade strategy is going to be different for each application. So what we're going to try and do is go over a lot of the different pitfalls that happen when you're upgrading and look at some of the exact examples of how you can upgrade. And hopefully this will better prepare you for upgrading your application and reasoning about the things that you need to do to get your application in shape for upgrading. So I've said upgrading, but we're really going to call this a migration. And I like the term migration for this because it's not a flick of a switch. You're not going to be able to just turn on Angular 2 and then have your Angular 1 app work out of the box. It's a bit more of a gradual process. So migration is a very appropriate word for this. And underneath the hood, the various options of migrations are very easy because you don't have to change your logic, but there is a lot of work, and there are a lot of gotchas in that work. You run into syntax errors and spelling mistakes and all sorts of other little things that trip you up that aren't complicated, but do require lots of manual effort and attention. So regardless of what migration strategy you choose, there's a number of things that are pretty well going to be constant throughout that. One of the first things that has to be done on most projects that are going to be upgraded from Angular 1.x to Angular 2 is to modernize the tooling and the project layout. And we'll dive into exactly what that means in a few minutes. The next step is typically to bootstrap your upgrader, whether it's ngUpgrade, which is what we're going to be talking about, or a different solution like ngForward. And then once you've got the next stage of your upgrade in process, the next step is to gradually migrate your services and components. And then test, commit, and repeat. And then finally at the end, drop Angular 1, assuming you're using the ngUpgrade path. So there's three different strategies for upgrading your application to Angular 2, or migrating your application to Angular 2. There's the total conversion strategy, the ngForward strategy, and the ngUpgrade strategy. The total conversion strategy is not really a realistic strategy. It would involve taking your Angular 1.x application and converting all of the code to Angular 2 and then seeing if it works. So right off the bat, you don't have any incremental validation. And what this ends up leading to is you working on a bunch of code that you can't test or validate, and you don't know if it works, and it ends up getting very depressing. And I don't think anybody wants that. Now, if you have a very small application, less than a couple hundred lines or something, or a toy app, then absolutely a total conversion is a good choice. But for any sophisticated application, it's really not going to help you out. ngForward is a different option. It's a third-party library, and its goal is to let you write Angular 1 in Angular 2 style. And this has some benefits, especially for older projects, in that you can write in Angular 1. It's pretty easy to get incremental validation, so you can change some code, make it look like Angular 2 code, commit, repeat, and move on, and that's really nice. But one of the downsides is that the templates aren't compatible with Angular 2. So what ends up happening with ngForward is that you end up getting your project into this Angular 2 shape, but then you have to go and adjust everything all over again at the end to get it to actually work with Angular 2. And there is a slight downside in that it's a third-party library, so support may or may not be long-term, which is unfortunate, especially with Angular 2's quick beta release cycle. So ngForward, it might really be good for really old projects that are in a Angular 1.2 or 1.1 style, where there's lots of dollar scopes everywhere and things like that, because it'll really help tame that code base. But for most Angular 1.3 applications and up, ngForward is not going to be a good fit. Now, ngUpgrade is Google's official package for upgrading Angular 1 applications to Angular 2. And ngUpgrade, it isn't actually, it ends up being a hybrid app. It's not just Angular 1 and it's not just Angular 2. It's Angular 1 and Angular 2 working together on the page. So the primary downside to this is that both Angular 1 and Angular 2 runtimes are included in your application. Other than that, it has most of it has actually more benefits than the other two options. The first benefit, of course, is that you can build incrementally, which is really great because you'll be able to make some changes, see them, commit them, and then know with confidence that your earlier changes are working while you're working on your new changes. It's also produced by Google, so you've got first-party support, and it's the official upgrade path that they're recommending. But there are a couple downsides, and that's that with Angular 1 controlling your page, and with Angular 1 controlling its bits of DOM and Angular 2 controlling its bits of DOM, some Angular 1 things like $compile don't really work if you're trying to use them in the Angular 2 part of your app. And we'll take a closer look at that as we get on with the webinar. But ngUpgrade is the strategy we're going to be recommending and talking about for the rest of this webinar. So before you get started, the first thing to do is to prepare your migration, and Varun's going to talk to you about that right now.
So before you even introduce ngUpgrade or Angular 2 within your application, there are a few things that you might want to consider doing on your existing code base. And these things will help you prepare for this migration, and will make things this transition a lot more smoother as opposed to if you did not do these things. So one of the bigger changes in Angular 2 is Angular 1 relied on an MVC pattern, and while you can still do that in Angular 2, the recommendation is to switch to a more component-based structure. This is a simple example here of a to-do app. So at the root, you have your to-do app component. Inside this, you have two components, the to-do list component and the to-do form component. And then the to-do list component is made out of several to-do item components. So this is the pattern that Angular 2 works great with. And in order to migrate, it's also recommended that you switch to this pattern as opposed to the MVC pattern and build out your apps using a set of components and nest them out into a tree of components. So when I say these components, what I mean is building out a component in Angular 1.x is essentially writing a directive. However, this directive has certain criteria that it needs to match. So here's an example of a Angular 1.x directive, or in Angular 1.3 plus to be more specific. So you start off by defining your directive, and in this case, it's just a simple example of a card directive that takes in a title and some sort of account, and then displays that in a template that's specific to your application. So you start off by declaring scope, and scope needs to be isolated, and in order to do that, I'm using an empty object here. The second requirement is a template, and this could either be an inline template or a template URL. And then for the logic for this directive, as opposed to using link or compile functions, we're going to be using a controller instead. And the reason for that is Angular 2 does not have any concept of link or compile functions. So if you have any logic within those two, it's not going to translate easily onto Angular 2. So therefore, if you rely on a link function, in most cases, it's fairly straightforward to move that into a controller. If you need access to things like the attributes and the element that is passed into the link function, both those are available to you in the controller. You can inject them as $element and $attrs, and still write out your directive the way you would expect it to. Now, along with this controller, we're also going to be relying on the controller as syntax. So here I'm just setting controller as to CTRL, but you're free to call it whatever you want to within your application. And then the last property is bind to controller. So if you're using Angular 1.3 plus, bind to controller can accept an object, and this object will become the scope bindings for your directive. So here I have two properties, title and account, and count, and both are bound as two-way binding properties. If you're using Angular 1.2, bind to controller is a boolean instead, so you can either set it to true or false. So in that case, you would set it to true, and then the properties that are mentioned here will actually move into the scope object instead. In Angular 1.5, the core team introduced another method to us, the component method. And this is essentially just syntactic sugar around what we did in the previous example. So you'll see that we no longer need to mention scope because scope is isolated by default. We also don't need to mention controller as. By default, controller as is set to $CTRL. So in your template, you would have to use $CTRL. However, you have the option to override it by providing the controller as property. And then bind to controller has now been switched to something called bindings. And the other really cool thing is we now have one-way data binding in Angular 2. In Angular 1.5. So here, when I set the title to this angle bracket, that specifies that title is one-way data binding, and count with the equal to sign remains as two-way data binding. If you like this component syntax, Todd Motto actually ported this back to Angular 1.3 plus. So I have a link here that will take you to the library page and a blog post about it, and you can grab that polyfill and use the .component syntax in Angular 1.3 plus. Just remember that would provide you with the component method, but not the one-way data binding. One-way data binding is specific to Angular 1.5. So if you're going to be switching to this component-based architecture and using components, another thing that you might want to consider doing is adopting a feature-based directory structure. And this is a simple example of that. So the idea is that instead of having all of your controllers and sitting in one directory, services in another directory, and so on, you have directories that are specific to a component itself. So if we have a to-do list component, the JavaScript, the CSS, the HTML, and the test for it all sit in one place. This makes development a lot more easier because you're not jumping around in multiple places to look up files and track where the different files are. Everything that you need to work on a particular feature sit together. And another recommendation from us would be to limit one component or one thing per file. And what that means is if you're creating a directive in one file, then that should be the only Angular method call there. If you needed a external controller and a service, each for that particular component, you should have separate files for them. Speaking of controllers, you should most certainly be using the controller as form in all cases, and ideally controllers should only exist on directives. In most cases, if you've adopted the Angular 1.x best practices, you are relying on controllers for routing only. So your route containers tend to have controllers and templates. So when I say limit yourself to using controllers only for directives, a valid question is then how do you handle routing? And the way we suggest doing that is you still use UI router or Angular router and you create states. However, now your states simply point to a component. So here's a simple example where we have the base route as our app route. And in this case, the template is set to the my app main component. And then there's a child state here where the template is set to the home component. So what this does is, since these components have their own controllers, all the logic and the template required for that route are bundled together as one feature, one component, and you don't have this decoupling where part of the logic sits in the component controller, but there's other parts of the logic that are sitting in some kind of wrapper that is specific to the route definition. All the logic in this case will end up in the component itself, and this makes moving things around a lot more easier because all you have to do is move a component from one state to another and everything just works as you expect it to. Next up, services. So this is probably the lowest hanging fruit in most cases. There's a good chance that you're writing services as a using the factory method. However, since Angular 2 introduced services to be simply a ES6 class or a TypeScript class, the .service method becomes a lot more appropriate. The reason for this is the service method expects a constructor function or an ES6 class. So in Angular 2, since we're going to be writing services as classes, we can start porting our services for our Angular 1 code into either TypeScript classes, ES6 classes, or even just functions that have of the constructor type, and switch to the .service method instead of using the .factory method. So we talked about how the component architecture is really important, and also since you're building out everything as a set of components, another major transition in Angular 2 is data flow is one-directional. You can introduce two-way data binding, and if you've been if you've attended one of our previous webinars, we've talked about how the two-way data binding is simply syntactic sugar around the one-way data flow and the event bubbling combined together. But the data bindings are still one-way. So in order to prepare for that, you should consider switching to that ideology in your Angular 1.x app too. And in order to do that, just a few pointers to keep in mind. So you really should not be updating state within any watch functions or within the component controllers. Definitely prefer one-way data bindings to two-way data bindings. So if you're using Angular 1.5, rely on the one-way data binding syntax. And then try to implement unidirectional data flow using libraries such as, like a Flux library, Redux, or even RxJS. So our recommendation is to switch to a Flux-based pattern, and our library of choice is Redux. But instead of talking about Redux specifically, I just want to give a quick introduction to what Flux is and how it ends up being a lot more beneficial to you in this component-based architecture. So we start off, so this is a simple flow diagram for the Flux-based architecture. We can start off at the view portion. The view portion is simply our Angular components. So we have a controller, we have a template, together they form the view. So now this view, in order to do something interesting, needs to have access to data. And we get that data from something called a store. A store in Angular 1 terms would be a service that provides data to you. However, this store within a Flux paradigm is slightly special. It only provides data to you through getters. The views cannot update that data and do not have access to setting that data in any way at all. It's simply one-way data flow into the view. However, if the view actually wants to trigger some kind of a change, the way you do that is by triggering an action. And an action is simply an event on a global pipeline called the dispatcher. And this action has a simple shape. The action expects two properties. The first one is the action type, and this is a unique ID of some sort that will be useful when we get to the next stage. And the second property is a payload. So if the action requires some kind of data to be passed into the store, that's going to be put under the payload property. So the dispatcher, like I said, is a global pipeline. It listens to all the actions that are being emitted from either the views or other services, or even server-based actions based on HTTP requests or sockets and so on. And it takes all of those actions and then simply dispatches them to the stores. That's it. It's really agnostic. It doesn't really care where the actions are coming from, and it doesn't really care who's listening to it. It just dispatches those actions to anything that's registered with the dispatcher. So these stores are registered with the dispatcher. So each store gets every action that's being triggered within your application. And then the store chooses to act on actions it cares about. So let's take the example of our to-do application, where in our view, we want to add a new to-do item to our list. So we would emit an action of the type add to-do. this would be dispatched from the dispatcher to the to-do list store, and then the to-do list store will look to see that the action type is add to do, and then it will fire off its action handler at that point to handle that action. And this is how you would update the state of the store. So the store at that point has the ability to check to see is the to-do that you're providing to it within the action of the right shape, are the properties the right types, and so on. And if everything looks good, then it's going to add that to-do to the list, and then push those changes out to the view again. And this helps a lot with the one-way data flow. So within your application, if you want to trigger an update, you trigger an action, the action goes and updates the store, and then those updates are then passed down from the top level component all the way down to the views. And this triggers a refresh within your application, and the parts that needed to be updated are then updated by Angular through the view synchronization. So another thing you might want to consider is adopting observables. So in Angular 2, the library relies on RxJS to provide observables. And if you've never worked with observables before, they're just another way of managing asynchronous data. You're probably used to using promises in Angular 1. Observables provide a similar but slightly different pattern. Instead of having a one-time binding where you create a promise and something happens, and once that action is complete, either the promise rejects or resolves. With observables, you create an open, a continuous channel of communication. You have the observable on the one side and the subscriber on the other side, and this observable is pushing out values. So here, when we push out the values like 12, 16, 19, and so on, the subscriber will receive those values and then update whatever data bindings that need to be updated based on that snapshot. So let's just quickly talk about the difference between observables and promises. In case of observables, you can define both the setup and teardown aspects of asynchronous behavior. Observables are cancelable, so a promise can reject or resolve, but unless either of those happens, you can't actually cancel a promise. And then also observables can be retried by using the retry and retry when operators. And really, observables are just are array-like. So you can apply operators on an observable like filter, map, merge, etc. And this allows for really powerful flows within your application. So I'm going to talk about one quick example that shows the power of observables. So in Angular 2, things like the HTTP service and the event system are now based on observables. So in Angular 1, when you called HTTP GET, you got a promise back. In Angular 2, you receive a observable instead. So RxJS, the observable object, has a method called fromPromise that accepts a promise and then converts it into an observable. So here's an example of how you would do that. Sorry, I actually just noticed there's a typo here. So the fromPromise should be passed in the promise variable as an argument, not $HTTP. And then that would convert this into an observable, and then you can subscribe to that observable. So whenever the promise resolves, you will receive an update with the value that you're getting from the server. So let's look at a simple example here. So the idea is you want to build out a search form. So here I'm using the Spotify API, and every time the user types into this box, you want to make an HTTP request, fetch the results, and display those results into your view. The important thing here is we want to build this out so that you're not triggering an HTTP request on every key press. You want to provide some kind of debounce time there. You're not going to, you want to be able to handle out-of-turn HTTP requests, and then also you want to, you don't have to worry about creating promises and then somehow handling those promises get destroyed, and or one promise timed out while the other one, which was triggered later on, fired first, and then the data is out of sync. So the way we're going to tackle this with promises is, so this example is using Angular 1. So I'm going to start off by creating a service. This service is called the search service and has one single method called search, where we create a URL for our endpoint and then create the promise that actually makes just simply our HTTP GET request. We convert that promise into an observable using the fromPromise method. And then we attach a map operator to it, which is simply going to fire every single time we get a response back, which will be 1 here because we're not retrying, and it just plucks the data attribute from that response and returns that to us. And then on the component side, we have a search component. I have some bindings specified here, but we're not actually going to be using those bindings. And then template URL and a controller. So in our template, you'll notice we have a simple form. We attach an ng model to that form, and the model name is query. And then we also have an ng change attribute on there. So this callback, the onChange callback, is going to be fired every single time I enter something into this input. And then we have our component controller. So here we're going to start off by creating an observable called query observable, and this is of the type RxSubject. RxSubject is simply an observable that you can push updates to from outside of the observable. And how do we do that? So that's what happens in the onChange method. You check to see is the query available. If it is, then you simply call the next method on your observable and pass in the update that you want to push to that observable. And then this is where all the action happens. So we start off by listening to this observable, which is, remember, this is the observable for when something is being updated on the input box. So every time a key is pressed, that observable fires and provides you the latest value. We start by providing a debounce to this, so a 400 millisecond debounce time. So this will prevent us from firing an HTTP request on every key press. The next thing we do is we attach a distinct until changed operator. So this will prevent the HTTP request from being fired off if the value for the query is the same as the previous one. So if I hit enter here, because this query is exactly the same as the previous one, you don't even make an HTTP request. And then finally, we have something called flatMap. And flatMap is just a slightly special version of map, which unpacks whatever is being returned from within the callback. So in this case, we're actually going to get the term the query term that's being passed to us, use that to create a new observable, which is of the type of an array. So flatMap will unpack that observable and kind of merge the two streams together. And then finally, when we call the .subscribe here, we're going to be returned the data that is coming back from our HTTP request. So all of this combined, what it ends up doing is now when I type, I'm not making as many HTTP requests as I would be by simply calling onChange. And then I'm listening to the HTTP requests that are coming out. And these HTTP requests will be handled in exactly the same order as they were triggered, and the final result is being provided to me, which then I can attach to my view controller. So trying to replicate this same flow with promises is much more challenging, and here you can see in just 55 lines of code, we managed to create this fairly complex flow. So another thing you might want to consider doing is migrating to Typescript. Typescript is a superset of ES6. It provides static analysis through type checking, and then also rich auto-completion in your text editor. Angular 2 heavily relies on decorators and types, so you can most certainly write Angular 2 without TypeScript or even ES6, but using TypeScript will make your life a lot easier. So in order to start your migration, if you're going to be adding new components, consider writing them in TypeScript. And then lastly, you should consider using some kind of module loader. And our suggestion is to use Webpack. We went into fairly detailed usage of Webpack in the previous webinar, so I'm not going to talk too much about it. But Webpack is fairly essential for Angular 2, or some kind of module loader it is, because Angular 2 relies on the ES6 module system as opposed to its own internal module system now. And Webpack makes this really easy, and it also provides a single interface for other types of files within your system. So if you have static assets like images or fonts or CSS that needs to be compiled from a preprocessor, Webpack will handle all of that for you and provide you a unified interface for all of them. And then, of course, Webpack will also handle transpiling TypeScript into ES5. So up next, Michael is going to talk about some upgrade examples.
Yeah, so we're going to look at bootstrapping, how to share components and services in between Angular 1 and Angular 2, and then lastly, how to just remove Angular 1 from your application when you're all sorted out. And again, this is going to be pretty high level, and it's just because every migration is going to be a little bit different depending on the application. So these abstract examples should hopefully provide you with a good footing for how to get started in upgrading. And one thing we didn't actually mention so far, but one of the most important things about upgrading isn't even preparing your application or anything. It's actually just reading up on Angular 2 and becoming very comfortable with Angular 2's flow and concepts. And because if you don't become familiar with Angular 2 before you start, you can end up in a situation where you're trying to migrate your Angular 1.x codebase to Angular 2, and you're having to learn Angular 2 all at the same time. So it's definitely worth working through a few simple Angular 2 demos, like the one on the Angular 2 page is great. We also have one in our NG course, which we'll share out a link for at the end. And working through a more complete application like that will give you a good footing for actually just making your migration a simple mechanical process where you're porting components and services from Angular 1.x to Angular 2 and not having to learn Angular 2 at the same time. So bootstrapping is in the ngUpgrade process is one of the first things, is really the first thing you have to do after you've gotten your code base organized for a transition to Angular 2. And in Angular 1 applications, bootstrapping was more often than not done in the actual HTML. So typically you'd have an index.html, and then somewhere in there you'd have an ng-app directive which bootstrapped your application. Angular 2 provides isomorphic opportunities with rendering web workers and on the server side and whatnot. And in order to achieve that, they had to pull the bootstrapping out of the HTML. So all bootstrapping in the Angular 2 world is manual, and bootstrapping in your hybrid ngUpgrade application is also manual. And because Angular 1 controls the page, you don't bootstrap Angular 2 the normal way. You actually use an upgrade adapter to bootstrap it. So we'll take a look at this upgrade adapter. Built into the Angular 2 package is an upgrade adapter constructor. And you get this when you do your npm install of Angular 2. So you don't have to do anything extra, but you do need to make it a singleton. And typically what we've been doing is making a single file for your upgrade adapter so you can share it out to the rest of your app. If you don't make your upgrade adapter a singleton and you put new capital U upgrade adapters throughout your app, you'll run into a whole bunch of unpredictable and unexpected problems. So one of the first things to do in bootstrapping is to set up an upgrade adapter file, import the upgrade adapter, and instantiate a new copy. And in practice, we've been using this file to house some of the other upgrade logic, just so that when the time comes to actually prune the upgrade, you only have to look in one place. And we'll look at that in a bit more detail shortly. So once you've got an upgrade adapter, you need to manually bootstrap your application. Typically in Angular 2 applications, there's a file called boot.ts, which just contains the bootstrapping logic. And the Angular 2 community is doing this so that, again, you could swap out your bootstrap function to use something that'll work in a web worker or on a web server. And there's even talk now that Python servers and Java servers and whatnot will actually be able to host Angular Universal. So that's pretty exciting. So in this code, we bring in our upgrade adapter singleton, and we call Angular 1's upgrade or Angular 1's bootstrap function. and we're attaching to the body. You could use a different HTML element if you wanted. And then we give it the application name and we tell it strict DI. You don't actually strictly have to use strict DI in Angular 1 from what I've seen in the applications that I've migrated, but it is recommended, so we're putting it there. And then to get Angular 2 onto the page, you use the upgradeAdapter.bootstrap method and put it on the document.element. And again, you want to pass it the same application name and strict dependency injection as well. So before we continue, it's worth taking a minute to talk about the different terminologies. There's 3 words that get tossed around a lot in migrations. There's upgrading, downgrading, and porting. And even in the context of this webinar, we've said upgrade quite frivolously in the sense that we're talking about upgrading applications. But when you actually get into working with upgraded services and upgraded components, these words actually have really specific meanings that are slightly counterintuitive when you're working with them. So I'd just like to take a second and review exactly what these words mean in the context of migrating with ngUpgrade. So the term upgrade is actually what would happen if you let an Angular 1.x component work in Angular 2. And that's true for a 1.x service as well as a component. So it's considered upgraded if it works in Angular 2, but that doesn't mean that it's actually in Angular 2 style or in Angular 2 code. It just means it can now work with Angular 2. And downgrading, that actually is pretty straightforward in that you would take an Angular 2 component and downgrade it so it can work with Angular 1. And we're also going to use the term porting, which is just to mean to actually convert an Angular 1 component or service into Angular 2. And so, again, porting is the conversion process. It's what you're going to have to do first. Because if you imagine you've bootstrapped your legacy 1.x application and you want to start using Angular 2, you're either going to have to write a new Angular 2 component or take one of your existing components and convert it to Angular 2. You can't just upgrade a component or service because there would be there's nothing in your Angular 2 portion of your code to use it. And then once you start getting some Angular 2 components made, then you can actually downgrade them because chances are your Angular 1 services are going to need them. So downgrading actually happens a fair bit. You use the upgrade adapter singletons downgrade ng2 provider or downgrade ng2 component methods to do this. And we'll take a closer look at actually downgrading components in a moment. And then again, upgrading is not the act of porting in this case, it's the act of letting an Angular 1 service work in Angular 2. And this uses the upgrade adapter singletons, upgrade ng1 component, or upgrade ng1 provider. And we will take a look at specific examples. So with a bootstrapped application, the first thing to do is, again, either to write a new component or service that works in Angular 2 or to port something. And we're going to look at the porting scenario. And so this would be taking one of those Angular 1.x services and converting it to Angular 2. And services are a good place to start because depending on your application, chances are there should be some service somewhere that has little to no dependencies. And these services are going to be the first things you identify and convert to Angular 2. The reason being, if they have no dependencies, then it's just a matter of converting them into a TypeScript format or a class and marking them as injectable. Once you've converted a couple services and you have things working, the next step is to find the next set of services that hopefully only now have Angular 2 dependencies, and so on and so forth until you've moved all of your services. So here's an example of a candidate service from a somewhat real-world application. This is from a Markdown conversion program. And in the original Angular 1.x code, there was a service that did the actual conversion to Markdown. It relied on a third-party library. It uses $Q, and in this example, you can see $Q has been assigned to capital Q, and there was some thought when this application was originally made that this was going to get workerized. So as you can see, this is already starting to get into complex, application domain-specific stuff. But this service was a good candidate to update because the only dependency it had was a third-party library and $Q. Angular 2, being designed for ECMAScript 6 and TypeScript, you have native promises right out of the box in there. So we can actually get rid of the $Q dependency and we're just left with the third-party dependency, which is effectively 0 dependencies that are Angular specific. So this is a great candidate. And so this was the Angular 1 code. It's been squashed a little bit to fit on this screen. So some of the tabbing and New lining is not exactly what you'd normally see, but that's just there for the benefit of readability. And then when it's actually been converted, it looks like this, where we've got an actual native TypeScript or ES6 promise instead of $Q, and it's still doing the exact same thing. It has an onReady method, it has the dependencies, they've been upgraded to use TypeScript types, and it's actually all been packaged up into one little class. So that's all it really took to convert this from Angular 1.x style code, and this is even kind of a weird look for Angular 1.x code depending on what you're used to, but again, we wanted to grab something somewhat realistic from some legacy code base you might have, and then it's turned into a class here. So that actually does the code conversion. We've marked it with @injectable so we can put it in. The next step is to actually tell Angular 2 about it, because it's a service, and Angular 2 needs to know about services. And typically with an Angular 2 service, we would do this by tapping into the Bootstrap injector, but we don't have one of those in a hybrid application. So instead, we call in the upgrade adapter singleton, and we call its addProvider method, and then we provide the class. And then lastly, we have to tell Angular 1.x about it so that we can use this service in Angular 1.x. And that's as simple as calling a factory method on an Angular 1.x app object. So this would be, angular.module. It's we're assuming that it's just been instantiated as app somewhere. And then instead of passing in the naked class, you call upgradeadapter.downgradeNG2provider on it. And now Angular 1 can use this. And then you're going to have to get used to dealing with problems. Even some of the simple examples, you'll run into a lot of red. A lot of these problems are going to naturally go away as you just fix typos, and a couple will stick around. But as long as your code's actually functioning, you don't need to worry about them, and in the end, they tend to actually just work out. So don't be too worried about the red. Just concentrate on making small incremental changes, and then commit. You definitely want to commit early and commit often when you're upgrading, because it becomes very easy to try and move something to Angular 2 and break a whole bunch of other things and then get caught in a cycle, and you just don't want to lose any working changes you have. So always commit and try and keep your unit tests up to date while you're going, which can be tricky. So that's how you would take an Angular service and port it. Now, porting a component is going to be very similar. Again, speaking back to what Varun was talking about, you're going to have to make sure that your Angular 1 directives are in a component style. The easiest way to do that is, of course, to use Angular 1.5 plus and use the .component method. But just in case you're using Angular 1.3 and you don't have .component, remember it's restrict to element, isolate scope, always with a controller as, and bind to controller, always with a template, and optionally require or transclude, which are built into Angular 1.5's .component method. And avoid at all costs $compile, replace, and priority. They won't work and they will break. And this is true of third-party components you're using. So third-party Angular 1 components are one of the things you're going to have to upgrade last. So again, just like with the services from Angular 1, you're going to want to look at porting your simplest components first, the ones that have the least dependencies or the ones that have dependencies that have already been migrated to Angular 2. And ideally, you're going to want to move the components that have the closest conformation to the component directive model. And don't worry about transclusion or projection. So projection, for those who don't know, is Angular 2's version of transclusion. Both of those features work in ngUpgrade applications pretty much plug and play. I have not encountered a problem with either of those features yet. So here's an example of a candidate directive from an Angular 1.x code base, and this is from the same code base as that last service we looked at. So it's in a bit of a funky style to begin with. You'll notice it's not a perfect candidate. There's a link function on here, and we'll take a look at that in a second, but it does have scope, it does use a template, it's not using replace, and it only had one service attached to it, so it seemed like a great candidate for upgrading. The only problem was this link function. So this is the missing link, and again, the formatting is a little weird because it's been squashed for slide, but there's a whole lot going on in this link function, but if you look closely at it, almost none of it is really particular to a link function. All of this could easily be done in a controller. It's just legacy Angular code. So the componentized version of this is going to look something like this, where we've got our selector tag, brought in the template. This actual template here is using Webpack's require method. So if you're not familiar with Webpack, that might be confusing to see a require in there, but Webpack will pre-process this and actually drop the contents of that HTML file right on the template. So Webpack is a really useful tool for managing your assets. And then diving into the actual class, you see label show, label true. All of these, you couldn't really see them on this missing link class, but they were all dropped right onto scope. So it just converted it to putting it on the class. And this would be, you could have done this by converting it to a controller as before, but sometimes you can get around this in just one step if it's a relatively simple component like this. And the ... dots at the bottom have just been cut off for brevity. I mean, it's none of the logic has fundamentally changed here. They've just been moved onto the class. Once you have the class, you just need to tell Angular 1.x about it for components. And all that is calling the directive method, putting in the selector, and this has to be in the Angular 1.x camel case format, and then calling upgradeAdapter.downgrade ng2 component, and then passing in your component class. And now you can use this directive in all of your Angular 1.x code, and you can use it in your Angular 2 code. So we've looked at porting and downgrading services and components, and that's great, except that some of the components and services that you port up to Angular 2, they're going to need to rely on some of the Angular 1 parts of your code. And so in order to make that happen, your Angular 1.x code is going to have to be upgraded. Upgrading works a lot like downgrading. It's actually just a little bit simpler because you don't actually have to change any code. So you would tell Angular 1.x about, say, a component, just like normal. The only difference with the component is that you're going to need to extract an Angular 2 version of that component. And you can make one by calling the upgrade adapter's upgrade ng1 component method on your component, and then take the value it gives you and pass it into the directive of the Angular 2 component you want to use. So in practice, this has all been done on our end in that upgrade adapter file, just so that later when it comes time to prune, it's a simple matter of going over that file and swapping out a few different dependencies. Services aren't shown here, but they work in a very similar fashion, except that you just have to call the upgrade adapter on them. And so once you've actually got some of these things ported and converted, it's a matter of just iterating over and over again and being very strategic about it. Certain things like third-party libraries that rely on $compile are always going to be a problem. So it might be easiest to come up with a good strategy and save those for last. Because then hopefully as time moves on and we're seeing some good commentary on different GitHub repos about Angular 1.x libraries being upgraded to Angular 2 and being made more compatible with upgrades, hopefully we'll see more movement from that from the community so that it's easier to transition your application. And there is a big push for that going on. It's still beta software, so a lot of these stories are still in completion. But you do want to be strategic. Save third-party libraries for last if you're not sure about them, or try experimenting them in a fork and make sure you rely on your version control. So once you've actually got everything done and your third-party libraries are upgraded or you've found alternate solutions, it becomes time to do a few housekeeping chores to get rid of your Angular 1.x code. So you need to prune the upgrade adapter, get rid of the Angular 1 registrations, use an Angular 2 root component. So Varun had talked about the component routing architecture. Well, the root component is essentially a directive that contains every other directive in your component tree in sort of Angular 1 terms. And so that's one of the last things that you put into Angular 2. And then drop the upgrade bootstrap, and then finally just bootstrap Angular 2. So we'll look at what that might look like. So pruning your upgrade adapter, more or less just deleting the file that does the upgrades, except for the fact that some of the services have been upgraded and bootstrapped this way. So you have to look for all of your add providers and make sure that those providers get added into your Angular 2 bootstrap step. And the Angular 2 bootstrap we didn't really talk about too much here, but it looks just like importing the bootstrap from Angular 2 /platform/browser, because this is actually going to be the browser bootstrap. Angular 2 provides different bootstraps for isomorphism, as we touched on earlier. And we'll look at that bootstrap code again in a second. So It's just, again, from the upgrade adapter, you really want to grab all of your providers out and make sure you bootstrap them in your Angular 2 application. The Angular 1 app registrations in Bootstrap can actually just be dropped because you won't need Angular 1 anymore once everything's been moved over to Angular 2. And then lastly is porting your root component. And there isn't a specific example here because it's different for each app, but typically you'll have a boot.ts and an app.ts, where app.ts is a smart component that is the root of your application and has HTML that in one way or another includes other components that draw out your whole component tree, which is a little bit beyond the scope of this talk. So that's why you really do want to become familiar with Angular 2 before you start. And your boot.ts just has that bootstrap logic. So it's going to import your root component, bootstrap it, and then assign your providers. And there is an example hybrid application in our ngUpgrade course, and this is a link that goes directly to it. And there's also a link to our ng course 2 book, which has more academic information about upgrades. The example hybrid application it just shows how to do transclusion and projection, as well as upgrading components, downgrading components, and making them work in between each component. Again, it's something that is different for each application, so you're definitely going to need to play with a little bit on your own to get confident with it. And so in conclusion, migrating Angular 1.x applications to Angular 2 is a lot of work. It can be very frustrating, but overall it's pretty easy. You're not having to make large logical decisions or worry about complexities of business logic. You just have to be meticulous in upgrading and knowing about how your different components depend on each other so you can move forward in a very intelligent and efficient fashion. And again, it's all depending on a case-by-case basis. So thanks very much for listening, and we'd like to open the floor to questions at this point. So we have a question about how stable is Angular 2 for starting a migration? And are they still going to add and remove features? Well, I can safely say they're probably going to add and remove features. I mean, it is in beta. However, the Angular 2 team has promised to really limit the amount of breaking features and breaking changes that they do. So there is some confidence to that. We're on, I think, beta 7 right now, and so far the breaks in the beta line have not been too bad. And the upgrades so far have been pretty stable because Angular 1.x is quite stable, and Angular 2 is it is in beta, but so far my experience with it has been quite stable. So we have a question on why a complete rewrite of the app is not valid from a business perspective. And that's a good question. I mean, there probably are some cases where a complete rewrite might actually be valid from a business perspective, but in most cases, in my experience, complete rewrites are usually a lot more work than you think they are at first. I mean, all of your business logic is still going to be in JavaScript. If it's been written in a decoupled fashion, that business logic is relatively portable to Angular 2. So if you've structured your application in a different way where it's been very, very coupled and it's a big ball of dependencies that are just a mess, then in that case, yeah, it might actually be a good use case to do a complete rewrite. But in most cases, a rewrite is just not going to be the right choice.
Right, so there's a question here that, or it's more of a comment that it's the wrong assumption that you can do everything in a constructor as you can do in a link function, and that instead you should rely on things like ngView after view init and ng after view checked. That's true. So our recommendation wasn't necessarily to move everything into the constructor. It was more moving things from within a link function into the controller, and the ng after view init and ng after view checked lifecycle hooks are available if you're actually going to be using Angular 2. However, in Angular 1, you don't have those lifecycle hooks. So even though you're transferring to a controller that's a class, those methods are not going to be available to you. So there are still certain edge cases where you cannot port it over to a controller completely, but generally you should port any link and compile functions into a controller instead. So there's another question about what are some common strategies for using $compile. And this really is kind of case by case. So generally, if you're relying on $compile, that's where you're building out. You're actually going to be compiling some template in on the JavaScript side. And really, like without looking at some specific examples, it's hard to recommend strategies here. But a common rule of thumb to keep in mind is think about whether you actually need to do that compile method within the JavaScript side, and instead try to move it into templates and maybe create a child component that will be rendered within the markup of the parent component. That way you don't have to rely on $compile. And if you rely on some logic to pick out what to compile, think about using stuff like ngSwitch or ngIf to pick and choose which version to compile.
So the question is, when should I try and sell moving our application from Angular 1.x to 2 to the business? And that's actually a really good question. And again, like everything else with these migrations, it does really depend on your specific case. And in most cases, or in some cases, you might have an Angular 1.x application that actually works just fine right now. It doesn't have too many performance problems. Maybe it's a smaller application. And in those kinds of cases, there isn't necessarily a great business case for moving it. It's more in the cases where you're running into limitations on mobile and where performance is an issue, or it's a new app and you want to be future-proof, where Angular 2 really starts to shine. So there are definitely some cases where it's going to be hard to sell Angular 1.x to a business just because everything is working. So if it's not broken, don't fix it. But in the longer run, Angular 1.x will eventually stop being supported. The Google team seems to be committed to supporting it for at least the next year, so that's not necessarily urgent. But 6 months from now, revisit it if you need to, and it might then be a better time if you have an app that's already working. If you have an app that has a lot of performance problems on mobile and whatnot, then Angular 2 is probably a better sell earlier on than later. So again, it depends on a case-by-case basis.
The next question is, why should I start rewriting the existing app? Why should I not rewrite the existing app instead of starting from scratch? So this really depends on your business considerations. You might be working on an app that while it is being transferred onto or being migrated to Angular 2, you still need to add new features to it during that process. In that case, migration is a better strategy. However, if you have a business consideration where you can pause and do a feature freeze and then rewrite the app in Angular 2 and then go from there, that's totally legit way to do it too. It just really depends on your specific scenario. So there's a question about performance benefits of Angular 2 over Angular 1. So one of the major performance benefit there is Angular 1 relied on the scope model and dirty checking to figure out what parts of the scope tree updated, and then go and make those updates throughout your application. In Angular 2, that whole cycle has been much more simplified because it's one-way data flow, and all that Angular has to do is simply traverse through your application tree one time, and then just simply mark things that were updated as dirty, and then trigger a refresh of those sections. So there's a much more simplified model of DOM manipulation. Less things need to be updated. In addition to that, you have the ability to choose different change detection strategies, so you can further tune that change detection to your application and really lock down what things get updated and when do they actually get updated. So just performance is out of the box is just so much better than Angular 1 right away. And there's some metrics available for this, which you can probably find quite easily by Googling it. But at this point, Angular 2 gives you somewhat similar performance to React, if not even better than React. There's a question about the ETA for Angular 2 release. Unfortunately, we don't have any information about that. The best place to get the information about that is the Angular.io website, or just check Twitter and follow the Angular core team. But for now, we don't really have any information about that.
So there's a question about React versus Angular if you were starting a large-scale web application today. And that's a really good question. I think there's a lot of people who probably have that question. I, like both Vert and I, work with React and Angular, and we have started web applications today. And much like the upgrade question, that is a case-by-case thing. There's merit to both frameworks. I guess in my opinion, I'd say React, it sort of depends on the developers that you have and how you want to work, in my opinion, with respect to React. Whereas I think in the React world, you need more of like a JavaScript developer, and you need to make a lot more choices, because React is just going to cover your view layer. So you'd have to choose your architecture, and you have to choose all of the other things that make your application work. And there's definitely nothing against that for some teams, but for other teams there is. Whereas with Angular 2, it's more cohesive in terms of large-scale web applications and providing you with all of the different tools you would need. And in Angular 1.x and in Angular 2.x, I find that instead of just needing like a JavaScript developer, you actually need an Angular developer. So that's how I see it. I don't know if you have anything to add to that.
Yeah, just like a simple example is forms. In React, you don't really have an out-of-the-box solution with how to handle forms and validation. In Angular, you get a really powerful form builder and powerful validation library built in, and then you can extend that with custom validation. So it really just comes down to personal preferences and how many choices you want to make when you are going to be building out your application. We have a comment here about how if you use ng metadata, that provides you some lifecycle hooks in Angular 1. So if you are porting over the link function and want to get access to those lifecycle hooks, look into ng metadata. I personally haven't done that, so thank you for pointing that out, and we'll look into it. Another question is, how close is Angular 2 to ReactJS? Like Michael said, the view layer is fairly similar. Both React and Angular rely on Angular 2 rely on the component structure and rely on actually building out your application using components. However, in React, the change detection strategy is limited to whatever React provides you, and there's just one change detection strategy there. In Angular 2, you get to pick and choose between a few different options, and depending on your architecture setup, you can switch between them. But other than that, the big difference is React only handles the view layer, whereas Angular 2 is a full framework that does beyond just the view layer and provides the architecture and other helper components and services to you. So there's a question about how someone is working on an Angular 1.4 app right now, and why would we recommend Angular 2 over other frameworks like Aurelia or ReactJS? So I think we've kind of covered that already, and we talked about the difference between React being the view layer and a library, whereas Angular is more complete solution and is an actual framework.
Yeah, and I would just add to that. I mean, if you're worried about having a buggy app, that's not really necessarily a framework-specific problem. You might do better to concentrate on getting the different units that are causing you the problems thoroughly tested so that you can work those out before you try and move that business logic over.
So there's a question about Angular 2's advantage for mobile. This is actually quite exciting. Angular 2 was built out with mobile in mind. It's built out to be mobile first. So the rendering and the updating of the view has been optimized for mobile. So that's generally a common complaint when building a JavaScript application or hybrid mobile applications, where performance tends to be somewhat slower. And because Angular 2 has been optimized so that you can still build out an application, and with the limited resources available on a mobile phone, it works out quite nicely. It's actually a really good fit. And of all the JavaScript frameworks, Angular seems to be the only one that has been focusing on mobile first with the version 2 release. So there's another question about React versus Angular and asking which one is simpler. So this is a bit of a tricky question. Again, because React only deals with the view layer, the API is actually quite small, and the reason for that is because it's only dealing with the view layer. The Angular API is quite large compared to React. And the reason for that is because it actually does a lot more than just the view layer. That might seem overwhelming, but if you just compare the view portions of the two frameworks, they're actually quite similar. There's very similar APIs. So if you get started with React and you find that comfortable, switching over to Angular 2 will feel very familiar because it's a very similar pattern to what you would do in React. The other parts where you bring in the services and the helpers, that is a different thing altogether, and it's a much larger and much richer API when it comes to Angular.
I would add to that if you already know Angular 1.x, like moving to Angular 2, it's a matter of sort of just upgrading the relationships you already have in your head to Angular 2 system. Whereas if you jump to, say, a React or an Ember or an Aurelia, then you end up having to learn a whole bunch of other things that you didn't necessarily already know. So there is a little bit of an advantage in moving from Angular 1.x to Angular 2.x versus switching to a whole new framework.
The next question is about the learning curve and the difference between the learning curve for Angular 1.x and Angular 2. So Angular 1.x was quite famous for having a pretty steep learning curve. Angular 2 is a much more simplified API. In my personal opinion, it's a much nicer learning curve and much less intense. I don't know if you have something to add there, Michael.
I don't know. It's I personally find it easier as well, and I don't know if that's like that I'm an outlier, which is often the case with me. But Angular 1.x, in some respects, for certain types of people who are more used to template-oriented design, it might be easier. But again, the API, it was so odd in some spots in Angular 1.x that it caused a lot of friction for people. Whereas in Angular 2, the whole thing's a little bit more cohesive. They've really developed and built on what they've learned over the last several years of servicing Angular 1.x.
So there's just a follow-up comment to that question where the person finds that when new members join the team, the learning curve is somewhat complicated. And yeah, like that is true for Angular 1.x, but with Angular 2, that onboarding becomes a lot more simplified because things are broken down into so many of these isolated components where you can work on those components and not necessarily know the larger picture and can still contribute much faster.
Yeah, it's an interesting point because it also depends on your team and your different team members' backgrounds and whatnot too. I mean, if you're onboarding developers who don't have a strong JavaScript background, that can cause a lot of friction on any JavaScript framework. Like it's just it does take a little bit to adapt to JavaScript if you're used to a different language. And if you're coming from being a regular JavaScript programmer and you don't know Angular, then you've got to adapt to the framework. But if you do know Angular, my experience has been that people who have knowledge of Angular do adapt to Angular projects pretty quickly because they're familiar with it. But and if you looked at a different framework too, like React, where you've made all these other choices, then anybody who you're onboarding to your team needs to know what architecture pattern you're using behind the scenes. Where are you keeping your stores? How are you doing all of these other questions that Angular does tend to provide a lot of answers for?
So the last question we have here is when is the recorded version of the webinar going to be available? There will be an email that will be sent out in the coming weeks with a link to the recorded video. And that's everything we had for today. So thank you for joining us for this series of Angular 2 webinars. And hopefully you can join us for some of the other webinars we're going to be doing in the future. Thanks a lot.